so let's start by defining like what are our success cases. Like what do we think the thing if the thing is working? So we can define like a test function which asserts or we can just do examples. So examples is going to be a list, and then we can start appending examples. So examples.append, and we can say hey and hello. That should map to 1, 2, 3, right? And then we can make more examples. Maybe that's not the simple example. Maybe like nothing and hi should be 2, and like what's another basic example? A and B should be 1, and I accidentally overwrote that, but hey and hello is and then what we want is, what do we do? For example, for pair value in examples, we want if f of pair, or let's say result equals f of pair. If result not equal to value, then print fail on result. Yielded value, and then I'm just gonna leave it at that. I'm really I used to write Python every day. Recently, I haven't been writing much Python code, so sorry if it's going a little slow. Hopefully this makes sense. So we have these test cases set up, and what I really want first pass is to pass all these test cases. And then the reason that I'm not doing this on like LeetCode, who will test my code for me, is because afterwards we can talk about like how to design our own algorithmic test cases to ensure that our algorithm is running with the correct like runtime that we're expecting. Okay. I don't think that's good, right? Okay, cool. So then we need to talk about actually solving the problem. So, well, let me give you guys a second first. Does this make sense? Like, this is the problem we want to solve. We want to know, are these two strings similar to each other? And this is actually like very, even though it's simple, it's actually very useful. Like, even in my job that I don't do that much, right now, like, one of my most important things is I'm introducing like Levenshtein distance between two strings to detect like, is this person equal to this person? Because before we had like two people's names and we weren't looking at the names to help us decide if they were similar or if they were the same person. Okay, I may assume that that all makes sense. Unless I'm like not talking or something. No. Okay.
No, we can hear.
Okay, so we have our test case, and now we just need this function that takes in a pair and returns a value. Maybe we should have called that like Levenshtein. I'll call it Leven of AMP. So what is this F? Leven. Okay. So what we want to do is we want to walk through both of these strings, and at any point, if we've already, this is the case for all dynamic programming problems, we want to set up exploration, where we say, we always start by checking, have I already been here? So let's say I'm looking at like, I'm at point like 2 on the first string and point 3 on the second string. if I've already explored that point and found the optimal number of edits to complete the strings, then, or to walk to the right of the string, ensuring that they're both equal, then I can just return that value, and I never want to do any computation if I already know the result. So we're going to compute, we're going to call this, often I see it called like memo, but just to be explicit, we can call it like known results. And that's going to start as an empty dictionary because we don't know any results. Cool. So A and B are our strings. And how, like, let me introduce my proposal for a basic algorithm here, because we haven't actually talked about the algorithm, although probably like that's really not important. I'm going to say, let's start at the very left of the array of both of the strings. In every state, in order to move to the right while maintaining consistency, if the values are equal, then you can just move to the right. If the values are different, you can either move one of them to the right, which would simulate dropping that value. You can move the other one to the right, which would simulate dropping the other value. Or you can move them both to the right, which would simulate changing one of the values into the other. Right? So if I have hey versus hello, if I move this L, if I just move my pointer to the right to the second L, that would, that would be the same as like dropping this L. I'm just pretending like that doesn't exist, and it costs me one edit to do so. I could also move them both to the right and skip the Y and the first L, and that would be the same as if I changed the Y into the L. Does the algorithm make sense? Does it make sense why I have these three options to delete one, delete the other, or change one into the other? Okay, let me know if you guys have questions. And please, anyone, if you're interested in like learning to be comfortable with this, please do it along with me. Okay, so here are our known results. So we're going to want a subfunction which just computes an update step. So I'm going to say def update step, and that's going to take in two indexes, so I and j maybe, and this performs an update. Sure. And then at the very end, what I want to do is I want to be able to call update step on 0 and 0, and I'm just going to return that. Cool. So what we want to do is we want to start from the left, calling this update step, and update should start traversing through both lists, and hopefully without doing any extra extra learning until it gets to the end.
Okay. Yeah, we should change the brackets to parentheses for your update step.
Oh yeah, nice. As I said, I don't write enough Python code anymore. Don't be like me. Okay, so we're gonna perform an update. Okay, so now we just need to write the update step. Cool. So what are the rules that we said? What's the first thing that we do whenever we're performing, whenever we're walking forward? We check if we already know the value. So we can say if I comma j in known results, then we return known results of I comma j. So hopefully these tuples will be the keys of our dictionary, and that way we can index easily. Okay, so if I and j are not in known results, there's one other base case that we can cover, and that's if a of I is equal to b of j. So we can say if a of I is equal to b of j, then what do we do? then we can just, well, actually, this is not the base case. I actually messed up. The other base case is if one of the pointers is at the end of the array, right? So if we've made it to the far right, actually that's the first base case that we need to cover. If we've made it to the far right of either I or j, then we should just know the value of that state, right? So let's say if I equals length of a, yeah, if a is like length 1, if I gets to 1, then good. If I is equal to length of a, then what's our value? So let's say, or maybe like everyone's just being quiet, so I'll just answer my own question. So if I is equal to the length of a, then all you need to do is wipe all the remaining values in b. So you're going to return, or you're going to set known results of I of j equals known results of I j. Oh, I guess we do this after here because we always want to check to set known results first. Okay. If I is equal to length of a, then if set the known results of I to j to the length of b minus j. So it's just whatever is remaining in b that you haven't covered. And then we're going to do the same thing. If j is equal to length of b, then the known result is a minus. And then we can, in either case, we can return, how do we want to organize this? I guess we can do like else. No, that's ugly. Let's just return right here. We might, I might want to restructure that. I think I had code that did this before. I forget how I organized this, but I'm hopefully just going to, I wanted to write this as a group instead of like referring to my old code, unless we really need to. Okay, so this is just our base cases. Now we have one last simple case, which is if AI and BJ are equal, then we can just return update step of I plus 1, j plus 1. Cool. Because we essentially get to move forward for free because the values are already equal. That's like the good case. Okay. So now is the bad case when AI is not equal to BJ. Okay, so here we said there were 3 options, right? So we can say like remove left equals, and so that's going to be update step of I plus 1 comma j. So if we imagine that we're removing a value from a, and that's the same thing as just walking I forward by 1. We also have a remove right, which is I and then j plus 1. And then we also have what is the other one? It's just impute, which is update step of I plus 1 and j plus 1. So we can move them both forward at the same time. Okay. Yeah, I think that's all. So here, what's the value of our current state? This should have been state value or something like that. But anyway, what's the value of our current state? It's going to be the minimum value of either removing left, removing right, or impute, and then plus 1. Because it took us 1 to get there. So we're gonna return, or so we always need to set known results of I comma j equals, and then that's going to be the minimum of remove left, remove right, compute, plus 1. I always forget this. Min 1, 2, 3. Yeah, it doesn't require a list. It just is a bunch of numbers. Okay, cool. Yeah, so that's most of the the basic algorithm is now laid out. We can try to test it. I wonder if it'll work. Test. Missing argument B. Oh, we needed to unpack pair. Oops. Oh no. None type and integer. Update step. Pair. Update step at 0, 0. Move both forward. Move both forward. Move one forward. Minimum of one of them is none type. Oh, whoops. Here we forgot to return this one. Okay. So we didn't get any errors. So maybe I should how do we do this? Let's just do errors equals 0. And here I can do errors plus equal 1. And here we can say if not error, if not. Okay, so this is not that interesting yet because we just wrote a very basic algorithm, and I'm going to try to claim that this algorithm is efficient, right? So by efficient, what should the runtime of this be, right? So we're walking from left to right. We shouldn't really see, we should just walk linearly from the left to the right of the string. So I think our number of calls should be linear with the length of the string, right? Someone call me out if that doesn't sound right. But what we can do is, the reason why we're not doing this in LeetCode is it forces us to profile our own algorithms. And so one way we can do that is with timing, but a more organized way to do this is by checking the number of times that this update step got called. So this is I don't know what's the word for it. If you do this during an interview, if you restructure and you formulate your code in a way where you can track the number of subcalls that you're making, this will be very impressive because people would like to be your coworker because your code will be organized. And so in this case, we're going to probably define a global variable. I would actually want to reformat this as a class, but we've made it a function, and so we're just going to define a variable. So we'll call this number of calls, and that's going to be 0. And so update step is just going to play with that global variable and say number of calls plus equals 1. So every time we call update step, we increment this value. And so we're actually not checking the cache until after we increment number of calls, right? And that's important because if we increment number of calls after we check the cache because we think, oh well, it's just the cache, then that's somewat cheating in a large way. Really, what we're hoping is by checking the cache, we don't track all of the downstream values that it had to walk through. Okay, so now let's see. Let's also, how do we do this? I guess we need to also return number of calls. And then, how should we design this? result, comma, underscore. Cool. Oh no. Oh, do I need to set global number of calls? What is that like? Or do I need to? Huh? I don't write enough Python code recently. Okay, there we go. Okay, so now that we have this basic and we have this like extra test set up, then we can start to profile our algorithm to see how many calls are we making. Is that from someone here? Okay, so I'm not going to continue profiling my algorithm until I get like some feedback. I have no idea if anyone's still on the line or something. Do you guys have any questions about how the algorithm's working, why we care about validating it? I'll zoom in on my code in case that makes questions easier. So the code is very basic, right? It's just checking is something in the cache, and we define what's in the cache based on what we thought was like the most efficient representation of the state of our algorithm, which is just to walk two pointers forward through these two strings. Does the algorithm make sense? So like put your, like you take two fingers. Here, let me change it to video. No, it's too much work. So you just put two fingers on like these two different arrays on the left, and you're just walking them forward to the right. Okay. If there are no questions, then I'm not going to continue with like profiling the system.
Yeah.
Sorry, Lee, I'm getting some errors. That's why I don't have a question. Trying to fix it.
No, it's okay. I don't need questions. I just think this was like covering the basic dynamic programming like walkthrough for Levenshtein. Okay, Matt, what's up next?
I mean, that was. Are you done with your presentation?
I think so. Like, I think
It's a little bit weird to do it online because you don't get as much.
yeah. If anyone's engaged, I can continue. But if there's no like follow-up questions, then I don't think there's any need to like keep going in this direction.
So Lee, I think this is very helpful, at least for me. I'm not really sure about others.
Did you follow along in code?
Sorry?
Did you follow along in code?
Yeah, I'm actually typing it up, which is why when I'm running there, I'm kind of debug it. But
Nice.
mind just one more time, just walking through this the update step, just one more time, slowly, please.
Okay, so ignoring this numcalls nonsense that I hacked together, so you're at step ij, right? So you're so let's say Jatin compared with J, and you're at this like let's say you're at J and J. So I and J, the letters I and J here, are both value 1. And so you want to know how many updates will it take to move these two pointers all the way to the right. And so you recognize, oh, these. So first you check, do I already know the value of 1, 1? You know, of J, J. And you say, no, I don't already know the value. Okay, so I need to figure that value out. So you look at this A, and they're both A's, right? So you don't need to perform any computation. You can just move these pointers to the right for free. and then you just need to evaluate kin versus y. And so that's what this is doing. So that's what this is doing. If the values are equal, then you can just move your pointers to the right for free.
Makes sense.
Moving both of your pointers to the right for free. But here, the values are not equal. So here you have like kin, and here you have y. And so you have two options here, or three options. You can either replace this t with a y, or you can remove the t, or you can remove the y. Right? Those are your only three options. And so what we do is we try to remove the t, we try to remove the y, and we try to replace one for the other. And then we just say, whatever is the best result of those three, then that's our result, right? You just need to perform one action to take one of those three, and then whichever has the minimum, distance to complete the problem from there, that's your result. And then whenever we find any of these results, we need to first cache it in known results. Oh gosh. Whoops. Known results equal. We missed one here actually. So we need to first cache this result, which we didn't do before, and then return it. So here we're first caching the result of, doing these three updates, and what is the value of I comma j, and then we're returning I comma j. So we never have to do that computation again. So then the last case, let's say here I don't know. Let's say we deleted the y. So we have ja versus ja. Ja tin versus ja. And then how do you complete this? Well, it's definitely, because there's no more letters on here, so the answer is just 3, because you just have to remove these 3 letters. And so that's what these lines are doing, where you're saying if I'm at the end of the strings, then my answer is just however many letters I have left in the other string.
Thank you. Very helpful, Lee. Thank you very much.
And then, we can always, the problem with timing is if I were to time my algorithm, the performance would be different between, my computer versus yours. But if I just profile the number of, calls that I make to my update function, that'll be consistent. And so, me having better hardware doesn't make it look like my algorithm is better. Or, for instance, on LeetCode, you can sometimes get a really good score for some problems just because, you got a good, server, I guess, that was, running your code, so it had a really low time. But if they were profiling based on, number of executions, then you would never, get lucky that way. Although this is not perfect, because this isn't actually a number of Python executions, but number of calls.
This is helpful. Just one last thing on this. So you mentioned that, obviously this is a common question in interviews, but you also have in your real life of you're asked to calculate the Lorentzian distance to find similarity between two people or something. Can you elaborate a little bit on the real-world use case for such type of
yeah, so I can't go into that much specifics about what my team does. The team that I'll be on for another 12 hours or something like that at Facebook. What? But essentially, this is very commonly used. So if I'm searching for a person, and if I type in the name Steve, my model can look at a bunch of people that people that I'm connected to that might have a bunch of different names, and some of them's names are something like Stephen Kavinsky. I don't know. And so the edit distance there, the Levenstein distance, is kind of large because he has this like huge last name. But if I look at like the Levenstein distance related to the length of his name, like the Levenstein distance is actually pretty small because there were a bunch of like common character patterns between the two names. And so calculating the Levenstein distance in like it's sort of like a search functionality where you're trying to find, like, if I'm looking for a person, who is the person I'm looking for? The Levenstein distance between their like string names is a helpful feature.
Got it. Thank you.
And then I mean the main point, I think the main point of like dynamic programming problems in general for interviews is it's a clear demonstration of like, can you create good coding patterns? Because most of these are not that hard, but if you were like working, like no one really cares how efficient anyone's code is, because most problems that you're trying to solve, you're talking about very minimal differences in efficiency, where it's not actually going to impact the company. But dynamic programming problems, just like across the board, have huge impacts. If you don't implement the dynamic programming algorithm perfectly, then your code runs at this like, absurdly horrible runtime. And so that's why I think dynamic programming is really important, because it's actually important for a lot of engineering jobs to be able to, like, when needed, make sure that your dynamic programming algorithms are running correctly.
I'm sorry, I'm a beginner. Can you just explain like the min argument, because it seems like wouldn't they have the same value or the same? Because if you're only going through each character once, wouldn't it just be one change or one count?
Yeah, sure. So happy to do that. So let me give it like a little healthier example. So let's do bouncing versus hello. This. So we're going to start at the beginning, bouncing versus hello. And so we have two options, or we have three options. We can either remove this B, remove this H, or change the B into an H. So I'll just walk through those. So here I have ouncing versus dot hello. So here I just removed this B. I could also have bouncing versus, and then I remove this H. Or I could switch this B for the H, which I could write like B dot ouncing versus H dot LO. Or I mean, I could specify like I'm changing this H into a B by changing it to a B here. But it doesn't really matter as long as my dot is to the right. So each of these took one edit distance, right? So each of these has a value of 1 from the beginning. But how far are they away from the end? So let me take one more step with this one. So let's say I start here, and then I could go to B ouncing versus HLO. If I just remove that B, right? So now I'm actually, like, I've already been here, like, this one, I only took 1 to get here, and this one I took 2 to get here, right? So I wouldn't want to remove this character, this H, and then remove this B in order to get to this state, because I can get to the same state by just changing this B into an H. So, let's continue with the problem. Let's say this is the right path, right? I was supposed to change the B into an H. So let's just really quickly wrap up the example. B dot do dot unsing versus he dot hello. I'm not going to really consider, like, I could get the answer wrong, but this should at least illustrate. So let's keep on going forward.
I think the answer is a match on O.
What's up? Wait, really? Oh, wait, this L was supposed to match. Let's pretend like that's not possible. But good point, Matt. Okay, so here at least I made it to the end. It'll still demonstrate the same point. So here we made it to the end. So this has a value of 3. Like, definitely this state has a value of 3 because it would take 3 edits to change bouncing from here to remove these ing. Here has a value of 4, here has a value of 5, here has a value of 6, and here has a value of 7. So then here, this state has a value of 8. But I could get to this, so what is this? This state, this one, this had a value of 7, which we saw down here. And this one had a value of 8, because we didn't really need to remove this H first and then remove the B. We could have just switched them in one step. So, like, this path was bad, and this path was good. And so that's why we take the minimum value, which is 7 here. Of course, I showed, like, a linear example after the first step, but realistically, like, all of the steps are going to have these trade-offs, and so that we, like, choose the minimum value for each one. Did that make sense?
Yeah, it did. Thank you. I mean, I might need to think about it some more, but yeah, it's very helpful. Thank you.
Like, sometimes it's better to switch the characters, but other times, let's say the example was like H hello versus hello, it would be better. H bellow. I don't know. H bellow versus bellow. In this case, it's not better to change this H into a B. It's better to just drop the H. And so the algorithm should be able to find that because it'll try dropping the H and then seeing how quickly it can get to the end. And it'll also try switching the H into a B and seeing how quickly it can get to the end.
Yeah, Ryan, essentially what you have is you have 3 operations and you're trying to try out every single one of these combinations in a recursive manner. Does that make sense? So you're traversing to the end of the string and you're trying out each of these 3 operations every single time to get you the most efficient implementation. Does that make sense?
Yeah, I got that. I guess I need to learn Python better, but I just was confused because if you're going one character at a time and if one step or one count is made, I thought wouldn't it just be one regardless, but like, I conceptually understand that, like, you're...
So are you talking about why we don't just return 1 right here?
Yeah, but...
Yeah. So
yeah.
the value that we're returning... Sorry, I should have been more clear about this. I was very non-clear. The value of every state is the number of updates from that state to make it till the end. So what you want to know is, like, let's say from this state... How long will it take to make it until they're completely matching? And so that's why we have to take the minimum of these, because each of these represents, if I take this action, how long will it take me to get to the very end of these strings to like make the strings match? And then I have to have this 1 just to say, I had to take 1 action just to get to these. And then these are the value representing how long to get to the end of the strings.
Great, thank you.
So does anyone have questions about like why did I use the location of these dots as my state, this ij?
So that I definitely found interesting, because I think alternatively would, I mean, this is something that kind of I wanted to mention because of some of the questions. Like with dynamic programming problems and with recursion, you try to get down to a base case, and in this case, the base case is when one of your strings is empty. In that case, you know that you need the length of the other string in order to actually that many number of changes, right? And so you go back a letter up and you're like, okay, now what's the minimum number of changes I can make to get to the next step? And using like the position, not the word itself, as like essentially the cache key, I found interesting because it does effectively the same thing, but it's not where I would have intuitively thought to go.
This is what I would normally do for like I guess this is my habit based on like always being prepared to interview, because if we use pointers instead of words, then it's really easy to explain with like fingers pointing at whiteboards. Maybe not good for like video conferencing, but yeah, I mean they mean the same thing, right? I can represent b dot ouncing versus h.lo by saying, okay, I don't really care about anything to the left of the dot, but I just have these characters to the right of the dot. And so you could have the actual string itself be the state. I guess you could argue like having the integers would be like slightly more efficient in your like cache, so you're not having to like your cache keys are not like these potentially really long strings and having just like tons of these really long strings, right? So I guess if you're talking about like O of n runtime, if your cache keys were the strings, then you would have like O of n squared memory utilization. Is that correct? I think.
Yeah, n by n.
Yeah, and so I think that would be like another argument where we don't want like n squared like an O memory utilization that's like an order larger than we need it to be.
So I think what might be a good exercise for some people is writing out what would kind of be in the cache in that n by n grid, if that makes sense. And so what you'd eventually find is that in one corner you have the value that you're dealing with two empty strings, and two empty strings are already equal, so the number is 0, right? And then you're essentially taking a step in either direction of, or any of the three directions of right, down, or diagonal. And at that point you're kind of doing your that is where like the meat of the logic is happening. I hope I didn't confuse anyone.
Yeah, I guess in that case, the algorithm is essentially saying if you want to move diagonally, you can do it for free if the string values are equal, but it costs a point if the values are not equal. But moving laterally always costs 1 point. I think that's like it would take a while to like go through that thought experiment separately. I just chose this one because that one would also be good. I just wanted the simplest like introduction to dynamic programming example.
Yeah, that would be like an iterative implementation, but I like this recursive memorize implementation.
This is just like the really standard like code that like developers are expected to crank out during like interviews and stuff.
Yep.
Except for this profiling thing where Lee forgot how to use like variables in Python. Okay.
Okay. Did you want to go further, Lee?
No, I mean, I don't think anyone really cares about the profiling aspect, and so I don't want to like, you know, talk about something without interest. So I think this was good.
I'd be curious what tools you'd use, because I've never done profiling.
The thing was like, what if you didn't want to use tools? Like how would you set up your own profiling?
So like either a timer or the num calls that you're using.
Yeah, with like what's the pattern of num calls against the length of the strings and against the Levenshtein distance between the two strings. So.
Okay. All right. Sorry, John. Did you want to say something?
I was just gonna say, Lee, this is very helpful. Thank you. Lee, would it be possible that we could post like one or two similar type of problems that we could solve in our own free time? I mean, there's so much on Leak code, but is there anything something similar that's not too easy?
I mean, it's essentially there's just like what is there like 7 or 10 like this guy is posting 10. Let's see if his are good. Yeah, like dynamic programming problems are like the classic software engineering problems where like what is chain matrix multiplication? Why is that here? I think of all the rest of these are the classic dynamic programming problems. Does anyone know like, what this thing is?
No, that's the classic too.
Okay, I just don't know what that is. Okay. Yeah, like
I would say 9 on that list. The coin counting problem. I think it's very intuitive. So basically, given any denomination of coins, or given any amount of like value, like $1.30, how many options can you break it up? Right, so you can make it $1, a quarter, a nickel. You can make it $1, 6 nickels, and all of those options.
Yeah, I think my favorite is like, the one that I was going to teach, but then I thought it would get too messy, is not longest increasing subsequence, because this is like a good starter problem. It's like, what's the longest subsequence where it like doesn't decrease, but implementing longest increasing subsequence skip n, that's like my favorite. So if you want my favorite, it's longest increasing subsequence skip n. And so the idea is you need to find the longest monotonically increasing subsequence. But like that's reasonably straightforward. But you also have this variable n, which says like it's allowed to skip n number of middle points, and then it gets a little complex.
Thank you.
Would you recommend any resources for learning dynamic programming, or would just Google suffice?
Yeah, I don't know. I feel like that's all I learned in college. Or like a large fraction of it. I guess there was also like other like search algorithms, but it was all related to dynamic programming. I would just recommend going through like the classic dynamic programming problems, and not like reading the leak code solutions, but like implementing them and implementing like the framework and like understanding them. Because all the other dynamic programming problems are really just variations on these. And these are just variations on each other. It's all just like, it's a pretty standard framework.
I feel like dynamic programming is, I think we're overcomplicating it. You just need to practice recursion and then dynamic programming will fall
No,
right into.
it's recursion plus remembering to cache all of your values.
Yeah, but the
So
remember,
with
yeah, you can easily learn the catching part, but I think the recursion is a blocker for most people.
Yeah, so
I think there's also another part that Lee brought up at the beginning where you're structuring the problem in a way that your variables are your state. And that is why you're able to like efficiently cache and actually use that. And I think that is the part that makes a problem actually like a dynamic programming problem.
I feel like that's one of the most valuable things for like being taught, like having some type of an environment where you're discussing problems, like talking through what should your state be in different problems. Sort of like seeing like code and seeing examples of this is how you solve this like recursive problem or this dynamic programming problem. Like I like the classroom environment, which is where I learned like, you know, what should the state be for my dynamic programming problem, and so that's why I wanted to use this talk to walk through that. Yeah, but like starting with just walking through these problems is valuable.
Thank you.
All right. Unless anyone else has any more questions on for Lee.
Did I turn this thing on?
In the bottom. Yeah. Okay. I mean, I guess the last thing to kind of do.
Thank you, Lee.
Yeah, thank you, Lee. The last thing we can do is talk through either things we want to see in the future or things that we should kind of be doubling down on. And so I brought up like we can talk about lectures, discussions, and the interviews, potentially doing interviews, and if you guys had any like requests or wants on that front.
Yeah, I got something actually. Hi everyone, I'm Ibby. I was here a couple days ago. I've been dropping in on the weekly sessions from time to time. But I had one thing that I thought might be interesting based off of something that's going on at my job that's a little bit more, a little less technical and a little bit more team oriented or infrastructure oriented.
Yeah.
So one of the things that I was wondering about is when people are building out infrastructure for, I don't know, one of the things that we're working on right now is machine learning infrastructure for growing data science teams. So trying to make sure that trying to get the best source of tooling and mix of cloud infrastructure together to support new engineers and people that don't necessarily building a good machine learning infrastructure for data science is something that I'm pretty clueless on, and it's one of the things that I've had to work on the last couple of weeks. And it'd be useful to hear from someone that's had to sort of be the first machine learning engineer or data scientist at a company that's a little bit larger now, and how they sort of thought about how to create tooling and infrastructure for employees that were going to come in.
I've built that for almost maybe all of my jobs, and the reason why me and a lot of other, all of the other competent machine learning engineers seem to quickly leave Facebook is because of how bad the machine learning infrastructure there is. So I think getting it right is important. But yeah, so what's the application of your company again?
I work for Peloton, the spin that's still bike.
So by machine learning infrastructure, you don't need to build any production serving of like user-facing infrastructure? Are you talking about like kernel infrastructure?
Yeah, exactly. So one of the things, for instance, is like I'm the only data scientist right now on at least the business end. There's 3 machine learning engineers on the product side, but I just hired 2 data scientists, and sort of the infrastructure that I've always worked with is I sort of just had a Jupyter Lab instance on an EC2 cluster, and that's sort of how I do everything pretty manually, and I have like really hacky stuff that won't work at scale, and I wanted to know sort of what other people, or like what tools other engineers use that make their lives easier. From I know we went over DBT. I implemented actually DBT at work right after we talked about it that one time, for at least 3 or 4 of the models that I use. But anything from like the data engineering ETL pipelining stuff all the way to deploying something internally to be used like with Looker or something to, like, I don't know, predict stuff. If that makes sense.
So have you? So like one of the most important infrastructure that you can build for these like internal groups is, have you abstracted away from like SQL and abstracted away from just like all of your data sources in like, let's say, Python?
No, we haven't. So like everything is still pretty SQL heavy because I sit on what used to be the BI team.
Yeah, but you can't like, let's say if I'm a ML engineer, it's a lot of extra work for me to, like, let's say I want to do cross, or what do I call it? Like a parameter sweep where I want to try out a bunch of different configurations of like features and stuff. If I'm having to like programmatically pass in variables that like define what SQL query is used to build my data set and then run my model, it's going to be like a very slow iteration loop. So one of the most important early infra that you probably need, or my guess, is you like, there's still like a SQL layer, but you abstract away from that, and so you build like a Python layer that knows how to get, like, maybe some of the meaningful machine learning data sets are like, some relations between tables, or maybe you need to like do some filtering. And so just like abstracting away from all of that, so the logic doesn't need to like live in people's heads, and different machine learning engineers use like different data sets. And so there's just like one communal like library that all the engineers can like share and contribute to, which is how they build their features for their models and how they define their metrics and stuff. That's really helpful, and without that you just like have chaos where one machine learning engineer says one thing and the other says the opposite, and it could just be because they're using slightly different data sets based on their filtering. So you need to abstract away from that first.
Interesting. That is a huge thing that I had not thought about. I might ping you separately to ask more details about this. But yeah, it's still like direct loop through SQL for the most part for everything. So cool. Thank you.
So
I could also talk at some point, if you want, about like how Facebook fails at machine learning infrastructure and like what all the problems are that make it like hard to do machine learning there, and like pitfalls to avoid.
Yeah.
So this reminds me of something that we brought up, that we talked about way back when, was having conversations around a product focus and then coming together as a group to try and hash out some like high level document on how to do it, right? So some of these examples were like, what if you have to build AWS from scratch, or what if you have to build Google from scratch? And so the general idea is someone would lead the discussion by like essentially acting as like a PM to answer questions on like what the actual goal of the project is, and then we can all kind of like speculate on, here's what tools you should be looking at to solve this problem. And I think, like, if you were to think about this in the context of Google, I think like for me, like you could come up with like a general high level strategy of what what Google search does, and then break it down into individual pieces. I don't know if that's something that you would be looking forward to, Ibby.
Yeah, that sounds awesome. Again, like I work for a company that is a marketing company, and I'm pretty like early. Like while like I have some engineering experience, like my actual like it's mainly academic, and so trying to like learn more about this sort of stuff and how to think of these like high level problems and predict what's going to happen when I have to do this at scale is really it would be super helpful.
Yeah. Yeah, I think doing DBT is a good step. I don't know too much about DBT, but you should ask Matt. And you can also ask Evan about Apache Airflow. I think that would also help you abstract away the SQL layer.
No, what? No, Apache Airflow for abstracting away for like a machine learning library?
Well, in terms of doing the ETL, because it seems like right now he's...
Yeah, that's for the ETL layer, but that's not for like the... Your machine learning library shouldn't be really related to your Airflow tag, right?
I don't think I think his main problem is ETL, not so much the machine learning.
Oh, is that it?
No. So sorry, I was being really confusing. I've solved most of the ETL issues. I solved most of the ETL issues. Have implemented Airflow. Mostly everything has been migrated to DBT. I was working on DBT when we were talking about it. It's just sort of like one of the ongoing projects that I have. The second thing, the thing that Lee was talking about is a little bit more relevant now. As I'm trying to move away and hire actual data engineers to do the data engineering side of it, like DBT and Airflow. But yeah, trying to abstract this sort of stuff away and start to think about these problems, because I do have problems with trying to implement the SQL layer within like trying to implement the SQL layer within machine learning, and it's just sucky. So yeah, like that would be super helpful. But thanks to whoever said that.
Yeah.
Helper functions.
Just be like Lee and do like pandas read SQL.
No. Even at PepsiCo, I set up like, infrastructure. The only like, in all my roles, I always set up infrastructure. The first step was just abstract away from SQL, so no one needs to write raw SQL code ever again, or for most cases, and then work in like Python and ML.
So when you say, can you go into more detail about this? Because like I use SQL Alchemy to do a lot of this stuff. I just build these massive data sets, and yeah, everything is really, really slow. When you say abstract away from SQL, can you give some examples on that?
Yeah. So
sorry if that's a dumb question.
So your Python code will always use some type of like Python SQL interface for running SQL commands and getting results, right? What you need is two things. So the biggest problem with running SQL Alchemy raw is SQL Alchemy. I don't think they have a default yet where they have a like parameter yet where you can intelligently cache your results, and then like if I'm running the same query that I ran yesterday to like get some SQL data and then pass it into my model, like probably I don't need to wait for the SQL data to come in again. So I need to automatically like cache the results of my SQL queries before I use them in my model. Hopefully in parallel, if you're dealing with large data sets. So that's one thing that like when I say abstracting, it's I'm not directly using SQL Alchemy or directly using any other like I think Edwin referenced like the Pandas library. Really, they're all mostly the same. You just have an interface between Python and SQL. And then probably there's a lot of business logic on top of your SQL as well, right? Like, oh, if you want this table, but you need to filter out these values. So a lot of like, especially if you have multiple ML engineers, you need a library which will handle all of that business logic for you. So let's say you can have a, get marketing filter or like get marketing function, and like you want to programmatically build the filters appropriately so the same filters can be applied no matter what data sets you're looking at, assuming the data sets are related and need the same filters. And then the high level, like, joins and the data sets that you're grabbing and the features you're grabbing, that needs to also be a like Python abstraction, where everyone's using the same library, the same shared library for generating their strings of SQL code that grab their data, and hopefully it's all being efficiently cached.
Got it. I see what you're saying. All right. Interesting. I had thought about that. Just because it's usually like right now it is just me, so I thought.
But then even if it's just you, doesn't it get like messy and you have to always like remember what SQL like what's needed for which data tables and which data sets?
As long as it works, right? Select star.
Yeah, but then what if you like look back on it a week later and you can't remember like, what does this column mean?
Yeah, the thing is like, yeah, I guess because like I helped set up a lot of those upstream models a while ago. Like, I don't know. Yeah, no, you're totally right. It is.
Right, you haven't forgotten yet. You're focused enough that you haven't forgotten what all the tables mean. But I bet it would be really hard to onboard someone else.
Well,
yeah, like it's
when you're gonna switch jobs every 6 months, you don't really care about making libraries. You just want things to work.
Edwin, he didn't start this call saying he was gonna switch jobs. He sounds happy with his job. He wants it to work better.
It's like you don't care about tech debt. You just want you just write some SQL, get it working, and use pandas, read SQL.
So I think there's multiple ways of doing it. I am not the biggest fan of SQL, but I do think there are places in your code base where it belongs. I think SQL is probably the best language to write like hardcore business logic. Like when you're literally like, oh, the price of something is the regular price times the promotion, right? To write those kinds of statements in SQL, I think is really good.
Matt, if that's your important SQL, wouldn't you want to abstract away from that so there's like a single function that grabs that appropriately, and all of your coworkers will use the same, what you're defining as like the important as the way to grab that data?
So I think the problem with SQL is a lot of the engineering things around it. One of that is SQL isn't a language where you generally have consistency around a lot of your data sets, and so if you use tools, and I think DBT is doing a good job in this space, of literally being the configuration around your tables, right? So instead of everyone making new tables, you make new DBT tables, and those stay connected in your repository and are like, oh, we referenced the users table, right? And the users table is a series of derived fields that get cached and updated periodically. And then when you reference those tables, you can call the SQL, and when you're declaring what those tables are, you're doing it within SQL.
Well, I don't know too much about DBT besides your lecture on it, Matt, but yeah, I have to disagree. I think because I've written thousands of lines of SQL to try to implement some business logic, and you would want it to have a higher level language than SQL to do. You would want the abstraction.
Yeah, SQL. Well, so SQL normally doesn't allow for the abstractions, right? You don't have.
Yeah,
Yeah, that's why the abstraction has to live in Python or some higher level language.
Yeah. You wouldn't want to like. I used to write some hardcore logic in SQL like directly, but it's not. You do like the objects are important in terms of like in terms of implementing business logic, and you want to use an ORM at some point.
Yeah, if you guys are familiar with like Python code, and then if you see like, these like 1,000 lines of like SQL code, and you're trying to read that, but it's actually just, it could have been programmatically generated with like 6 lines of Python code. It's really pretty to, to look at the 6 lines of Python code instead of the thousands of lines of like SQL code.
So
It's
I
really easy.
agree that if your SQL code is that long, you should look to like apply dry principles and stop and figure out where in your code base you're repeating yourself. And so there comes the idea of like views or intermediary tables in SQL. SQL itself has like, I think Postgres implemented something either with columns or like virtual views, where.
Wait, are you talking about like case when? I'm just talking about like there's a bunch of like case when statements and other things like that where you don't like all of the does a virtual view solve the need for those?
So
you would be able to bulk them all together, so you're not. The idea is you're able to repeat yourself a lot less, and so that solves a lot of like your abstraction problems.
Well, it's not elegant, right? If you're creating all these virtual views, you might as well just use like an object-oriented programming language like Python.
Yeah, abstracting into an object-oriented language, or like just in a language that supports like functional generation and iteration on all these things, I think it makes things really nice.
Yeah, it's just not pleasant to, because I've had to write like very low level. I had to write SQL to make it very optimized, and what I got in terms of efficiency, I lost a lot in terms of developer productivity. If that makes sense.
do you guys? So quick question, Edwin and Lee. Do you guys cache these? So one of the issues that like Peloton's grown really quickly, and one of the issues that we've had also is just like, oh my god, the data infrastructure is just terrible in some places, and so like one of the ways that I can solve for like the huge amounts of SQL that you might have to generate is that we have data models that handle a lot of that stuff for common business cases, which is really good, and being able to not have to being able to quite literally do like select star and have good tables with relatively few joins isn't super hard, but one of the things that one of the issues is that Redshift's infrastructure, which is what we use for just the general analytics database, is slow, and so I want that to be cached somewhere. You guys do any of that sort of thing?
Wait, yeah, that was the main thing that I said. Like that was one of the 2 main things that abstracting away from the Python SQL interface gives you is you always cache your results of every SQL poll, right? And so hopefully you have like an argument where the only problem with caching the results of your SQL poll is if I want to see the like new data from today, even though I'm writing I'm running the same query as yesterday, but if I need to see updated data, so your infrastructure needs to support like either not caching the data if sometimes that you don't want to cache something and you're running it like on a rate, like you publish something so it runs every day, or if you need to load new data, you need to be able to like ignore the cache. And so when you build this infrastructure out, you need to be able to not only just ignore the cache data and load query for new data, but you also need to be able to push that to a like per subquery basis. So if you're I guess that's if you're like running multiple queries to grab multiple data sets and you've abstracted in Python, and then of course like each one should be able to, like does this data table need the updated data, or is this just like a mapping table and we don't need any updated information? But yeah, I mean, cache your results.
Thanks.
And then the way to cache your results, you're probably going to need to use some, what's it called? Like, there are random hashing algorithms. I forget the name of the one that I usually use, but essentially you should take the full string in SQL and it should output like some random hex pattern that compressed that SQL string.
And then you probably want a time on it too, or a TTL,
What? Why?
or not a. Oh no, not on the hash actually. You're right. Sorry, my bad.
That's cool. Thanks.
I think this could actually turn into a larger discussion. I like one of the big things that I wanted out of a meetup is having a group drive at one or many like best architecture practices, right, and being able to kind of choose technologies across the stack, right? So, like we clearly have experienced that like certain technologies work well together, and I think as a group we can kind of brainstorm about like what is the best technology stack to solve problem X, Y, Z, and kind of talk through a lot of the high level details that could kind of help us make those decisions. So recently in my own work, like I find that a lot of times you end up having to make a lot of decisions where you're like, I wish I could just defer to someone else. Recently this came with, I had to pick like a CSS framework for a UI, and I was like, I just want someone who knows better than me on this to make this decision. And you know, you end up having to read into things that you don't want to spend time reading into.
So should we all build beautiful machine learning infrastructure that does basic tests and simulates and conditions on, like SQL data environments? I love that.
I mean, I think some diagramming around that would be helpful, and I also think like having someone literally play product manager and literally make up scenarios and be like, oh, do we care, like, for how many users it's going to be? Oh, it's going to be for 10,000 users requesting one today. Okay, let's drive out like how we think that should shape our engineering decisions.
Let's do Ibby's job.
I mean,
Honestly, I'm so frightened.
You're so what?
I'm just kidding.
Oh, okay. I thought you would be excited. I would love for like a group to discuss how to make me look good at my jobs.
No. I meant that the things that are to come, the problems that I have at work, that's what I'm frightened of, not frightened of.
Oh, what are the problems? So it's just like cleaning up your ML infra and being able to like support having a group developing these things?
For the most part, yeah. I think there's that. There's also a ton of like, I mean, yeah, there's just a ton of tech debt, which will always be a thing, but the two issues that I'm dealing with are cleaning up ETL and making it so
you're marketing org, right? So the main thing you have to address is you have to tell them like which of their marketing spends are not only like correlated with increasing sales, but like what's causing the increasing sales, right? Is that your job?
Some of it. Most of it is around user churn prediction, trying to understand what most of it's like churn, right? Like trying to forecast churn and then build out pipelines to fight.
But then you need so churn is always like the version 1 thing that you try to solve, right? You're forecasting like how much churn, which users will churn, and then version 2, right, is like conditional on if I give this user this offer, how much less likely is he to churn? And then, you know, the offer, the incentive you're giving this user that has some costs associated with it. And so then eventually, I mean, you're always doing churn analysis, but it's just, you know, you're having like machine learning, like math on top of churn analysis where you're trying to like, you know, maximize, like ultimately you're maximizing the overall profit of the company, but you're doing so through like minimizing churn as a function of also minimizing like the cost to retain users. Right?
Yeah.
Is that accurate, or am I missing something?
No, yeah, that's perfect.
I've done this like quite a few times. Sorry.
Lee's the marketing king. Marketing LML king.
That's so embarrassing. You know, yeah. The marketing team that I almost joined at Facebook is actually like more advanced than my team, but I didn't really want to stay in marketing.
Yeah, Matt. In addition to all the SQL interface and the Google clone, the AWS clone, I also humbly request we have to go over game engine architecture, and I can help offer input on that as well.
You missed it, Edwin? There was a guy here earlier, the first guy who talked. He started out talking about game engine development.
Who is it?
Andre?
Andre?
Yeah, Andre.
Really?
I missed that.
I missed
Well,
that
he'll be
too.
back.
You surely?
Yeah.
What?
How do you guys miss that? I'm sure. He was talking about oh, he saw that we were talking about this game engine stuff, and there's oh, this other game engine, and oh, but they built this thing, and then it wasn't as advertised. I don't know. I don't know what.
Oh yeah, he did have an anecdote.
No, yeah, but in terms of actually going over how best to structure the architecture. Yeah.
Oh yeah, he didn't do that. Sorry.
I think you may be the only one that could contribute to that. So if you want to give a lecture on it,
I mean,
do that.
like Lee and Ibby and you can contribute to the data side, right? There's a lot of data that comes out of these platforms, right?
Oh, I see.
Yeah.
I'll contribute on the user feedback side. I'll tell you what game I want.
But that's just my humble request.
You're very welcome.
What would that be like? So we would have a game architecture, something like a MOBA. How would you design the server client architecture for a MOBA? How would the communication work?
Yeah, no, not even, because there's so many things that come into engines. There's not only the data side, there's also the networking, web side, and I'm sure a lot of people here can contribute to the web architecture side of these multiplayer network games, stuff like that.
I feel like
Yeah.
I'm thinking of how to implement it as a JavaScript website with HTML. That's the only way that I know that I guess that would be a good conversation, but I imagine that's quite different than the Unity and all that.
So the networking aspect of how do you deal with these high traffic games? I have to say, as an anecdote, I horribly failed that part of that was a significant part of my interview for Facebook, and I horribly failed it, and they said that I passed it with flying colors. So I'm convinced very few people understand that stuff because I clearly don't, and somehow I passed that part of an interview. So just saying, if you don't think you're an expert, Edwin, I don't think anyone else is an expert either. I think everyone's, we can try to figure it out, but I think everyone just has to try to figure it out. Any company wanting to stand these things up.
Yeah, no, definitely. And I think it's a useful skill to have, because having real-time, low-latency multiplayer servers, I mean, I feel like that's even beyond gaming. That's a very important.
Isn't that the same problem as what Facebook or Twitter or all these companies? Essentially, it's just how do you handle real-time connections with a lot of data between groups of users?
Yeah, exactly. But with graphics and physics included.
But a lot of the graphics and physics, you just intelligently push that to the client side for processing. Right?
Yes, but let's say that it's, especially with things like pixel streaming coming out, a lot of these servers are actually being run in the server side. So imagine an AWS that's running your graphics for you. That's basically that's the future. That's what's happening now. Instead of you using your own GPU.
Yeah, but you're still not communicating like any complex graphics computation. You're just sending the raw data to AWS, and AWS is like doing some computation and then sending you the pixel values. Is that what's going on?
Something like that, yeah. Basically, like they're sending you a stream of the video, a video stream.
Yeah. So they're sending you the pixel values, and they're the one doing all the computation. Yeah. So should we set up like a basic? What would a basic version of that be? Just like
Well, basically, you have to set up AWS, and then you have to put the game engine. You have to combine it with the game engine.
I feel like we should not do implementation. We should just talk about it and talk about how we would do it, and then move on to like other things. Because the difference in that is like an hour-long discussion versus like 20 hours of like setup time for a server.
But then we can be so proud of having built it.
Well, imagine if you ran a pixel streaming company, Matt. That would be that would be great.
That'll be amazing.
The guild could become like our new video game startup.
Studio.
Oh, that'll be awesome.
But yeah, that's just my. I mean, I can go over more of like game engine architecture, but obviously I'm still a neophyte at this kind of stuff. So.
Yeah, I mean, I'm slowly starting to like the idea of getting someone that like is an expert on the business logic to like ask a bunch of questions that help drive out a bunch of engineers being like, oh, here's what kind of database you should be using. Oh, here's what you should be doing in streams. Here's where you should be hosting your like processing work that's done on the stream. And that I think is an engineering conversation that like most people can contribute in some way, as long as someone's there kind of providing the like actual context, the business context.
Hey, Edwin, there's anyone you follow on YouTube that kind of like stream those type of content?
Well, that's what the pixel streaming video games are like. You actually can, if you use like Google Stadia or one of the other competing services, you would play these video games by streaming, and it would use their servers to run most of the GPU intensive tasks for you.
No, but there's anyone on YouTube that kind of like stream those games, like, and explain how it works, like under the hood?
Well, most of these gamers don't know anything about development. I mean, we know more. Yeah.
Right.
Like, a gamer needs to either be a comedian or a professional gamer. They don't need to be like a software engineer.
Yeah, these Twitch streamers don't know like a lick about development.
No, exactly. So, do you know of someone that is actually a developer that streams those kind of things?
I don't know anybody. I guess I can send some emails out, but I don't know any professional game engine developer.
Oh, okay. That's interesting.
Who does ML for games, and he also plays games professionally. But I think he's like a wonderful guy, but I think he has even less engineering experience than me. So yeah.
Okay, no, well, I guess I'll just I can give a quick overview of everything, but obviously I'm very interested in this kind of stuff, so it's a learning process. It's going to be a long-term kind of deal.
Matt, what do you think?
Yeah, I mean, I feel like I've said where I think this goes, which is having someone drive out, like, lead it, but then having people kind of propose their solutions to whatever problems a person brings up. And I think the game engine architecture is a good one.
Right.
And okay. No one seemed to bring up interviews. I guess that would people be interested in things like that?
I want someone. Yeah, I agree with Edwin. I want interviews with like a video game software engineer. Like, who is going to be the subject of the interview, right? What are
Is
we all
there
like
someone that would like
video games?
okay, so your example is someone that's in that programs video games.
Yeah,
Okay.
and ideally on like the not on the front end, right? As close to like the systems and back end side as possible.
Okay.
Edwin, is that what you'd be interested in as well?
Yes, 110%.
Okay, good. Our line.
And remember when we had that discussion around like how COVID is going to change the tech industry in general? Did anyone have any other related discussions that they thought might be interesting to do in the future?
As long as it's related to video games, I love it.
Not enough video game content for Edwin. All right.
Yeah, I agree with Edwin. I'm going to be working on, well, assuming I get this offer in the next day or so, I'm going to be working on building actually ML infrastructure. That's like the startup that I'm joining builds that. So if I don't see the group, oh yeah. So anyway, if anyone's interested, that'll be what I'm working on.
Like full time? Or that's what you'll be doing as a project in between jobs?
What do you mean we are live, Tom?
Be careful.
Oh, shoot. Yeah, okay, never mind. I didn't say that. I won't comment on that. Good point. No, I mean, as a passion project.
Open source. Open source.
Yeah, open source passion project. Good point. All right.
Hey, I gotta jump off. This was really fun, though.
All right, later, Abby.
Yeah.
I don't have anything else.
We are live though. Is like, what is that? Where is this thing being broadcast? Is it just to some YouTube channel?
Yeah.
Yeah. We're gonna look through today's because both you and Andre said some things that we want to filter out.
Oh, nice. Yeah, sorry about that. I should have been more cognizant.
No, it's okay.
I should have said
Andre
something, and then he showed his Bash profile, and sometimes people keep secrets there, and so I want to make sure
Yeah.
that we didn't broadcast anything.
Yeah, that's already cut it out. So, yeah, no worries.
Yeah, so we're hiding them, and we'll look through them again. Yeah, I should have said it right at the beginning, but that's also like and then I was considering saying it as you guys were going, but I felt that it might be distracting for you guys to like hear that.
No.
What did I say? What do I say next?
Like trying to teach during the without seeing anyone's reactions. I had no idea what was going on. Hard.
Yeah. Edwin, I'm sure you feel the same way. I certainly feel because you don't get the feedback, and it's almost like you wish someone had their mic off so that you could at least get something back.
It is very tough to do it.
So I'm wondering if we should move away to other formats.
Yeah, everyone's videos need to be on constantly. Audio's on constantly.
Yeah, that's the point because I still know what some of the people in the room look like. You know what I mean? So it is a little bit. I think.
Yeah, if they're cute, then Edward wants to put in more effort.
I wouldn't want to see 50 neckbeardy men, but
I was kidding.
But no, but seriously though, yeah, I do like, yeah, I feel like if everybody like had their video on, I think that would be better.
Actually, yes, that's one thing that I was going to propose today. So you guys cool with like everyone with the video on? There you go, Matt. Started.
There you
Yeah,
go.
I like it. It's like, you know, it shows engagement. You
Yeah.
know, it helps the presenters.
Yeah. Well, it builds a better community too, because you can actually, you don't know that like these aren't like catfish. Catfish.
Yeah, you know they're not ugly girls. That's Edward's point.
Oh, we definitely like Tom. Please cut everything in the past hour.
There needs to be a filter on you guys.
Yeah, I'm thinking to not stream this.
We are a family-friendly YouTube channel.
But yeah, I think mandating the video, I think is a good idea.
I think we can just get a few people to do it.
I don't
I'll
think
do
you
it
need
next
to
time.
mandate it. If we just encourage it, that should be enough, right? Because, like, it can't be mandated. What if like, I don't know. Like, yeah, I gotta keep it family friendly, but like, I wouldn't want to mandate videos.
Yeah.
Lee, actually, are you back in New York or?
Yeah, I just moved back a couple days ago.
Oh, nice. Okay, welcome back.
That house was way too full of insects.
How's the city?
It's fine. Yeah, I mean, like, if I'm just staying in my apartment anyway, like, now my apartment doesn't have insects. Other than that, my quality of life is the same.
All right, I'm gonna go get some pizza, but yeah, I'll talk to you. Yeah.
Talk to you guys later.
All right.
Oh, I see Matt. Oh.
Good night, everyone.
All right. Bye.